Thank you very much, Travis. I'm not so sure about mad scientist anymore. I just got a new haircut, so I'm looking all slick. I'm no longer the mad scientist. But I'm very excited today. Welcome, everybody. Hello. I'm going to be live demoing the new EverCore product. I'm very excited to. I'm going to be speaking mainly about 4 core components inside this solution. The first core element I want to speak about is this hybrid inverter being on the outside. As Travis highlighted, it is IP66. Most of your installers will be very familiar with the interface and setup on that hybrid inverter itself. Even if you're not familiar with the 125 kilowatt hybrid interface and commissioning process, its interface is very similar, exactly the same, I would say, as the 50 kilowatt, the 20 kilowatt, even extremely similar to our single phase 3 kilowatt hybrid solution. One of the other things that Travis spoke about was the structural separation on these units. So we've got the hybrid inverter outside, and we've got our DC battery solution inside. Notice how simple and easy and neat and tidy the wiring is for this cabinet. And just to note that there's a lot of hidden cables behind the trunkings and these plates here, and all of that wiring is done before in our factory in China. So the only wiring that the installer actually needs to do at the end of the day is these power cables running through to the hybrid. There's a communication cable running through to the hybrid, and then the hybrid has got a set of 3-phase AC cables running back into the cabinet, powering up our aircon. The second core element I want to speak about is the physical batteries themselves. So inside each pack is 20 cells, 314 amp hour cells. There's 20 cells in series, making up your 64 volt, 20 kilowatt hour battery pack. There's 13 of those packs arranged in series, giving you this 14th pack, this white box that looks like a battery, is not a battery, it's our high voltage box. Very, very important component in the system. But your 13 packs arranged in series give you your 832 volt solution, and that is the 261 kilowatt hours battery cabinet. Then I want to jump our minds into the inside of this pack itself. So I'm going to use this empty pack to demonstrate this idea. As Travis mentioned, we've got these slits running along the side of the pack. And on the packs behind me, the real packs, and the packs that you would receive on site, there will be metal inside these slits, creating effectively a heat sink. And then your physical cells are placed between those heat sink fins, giving a very good thermal conductivity between all the different cells inside the pack. Meaning, the most important thing about that is that when a temperature change happens on one of the cells in the pack on the further side will also be changing by that same temperature very, very quickly. And that's going to bring me on very nicely to my third core element I want to speak about, and that is thermal management inside this cabinet. So we should all know that with lithium batteries, we probably don't always need to cool it down. Quite often in winter, we actually need to heat it up. So what the EMU will do, the energy management unit will do, is it will detect a low temperature state on one of the cells inside this pack, for example, and it will make the clever decision to fire off a control command to the air conditioning unit, which can heat and cool, to then turn on, and it will shoot hot air out of the cabinet in the case of winter. It will shoot hot air out of here, and then we got to imagine that this door would be closed. It would shoot that hot air down these air ducts to the back of the cabinet. The hot air will then arrive at the back of the cabinet, and if we divert our eyes back to the pack here, the hot air will arrive at the back of the pack and run along here. And the EMU would have told the fan for the pack, which has got the cell at the coolest temperature, to turn on, which will then suck that air out of that pack and back into this chamber. Effectively, evenly and effectively transferring that heat energy into the cells themselves. naturally balancing the cells. So one of the main causes of cell imbalance in a system like this would be irregular temperatures between cells and packs. Moving on to the fourth core element I want to discuss, and that is safety and protection. So just going through all the safety features inside this cabinet, we got our temperature sensor for the cabinet at top here. We've got our smoke detector next to that. We've got our Honeywell gas detector on the side of the cabinet here. Behind that, we've got our aerosol fire suppression unit. While I'm talking about aerosol fire suppression, inside each pack themselves is aerosol fire suppression. There's temperature and voltage sensing inside the pack, as well as inside each cell, there's a pressure release valve. Moving outside of the pack, we've got our EMU on the wall there, probably the most important component in this entire system. It stands for Energy Management Unit, as I said, and that's exactly what it's doing. It's communicating to all the different safety features, it's communicating through to all the packs, it's communicating through to the high voltage box, it's also communicating through to the hybrid inverter, controlling them, making sure that everything is safe. Very, very important component. Then below that, we've got our internet router. We want to get our EMU online, we want to get our hybrid inverter online, and we just want a single internet cable coming through into the cabinet to get all of that online. So that's the function of the router there. Our humidity sensor is located inside the air conditioner unit, which sends its data through to the EMU. Below the air conditioner unit, we've got our explosion-proof exhaust fan, which turns on when gas is detected in the chamber. At the bottom of the cabinet here, behind this plate, we can't see it, but there's a water immersion sensor. And then on the other side of the door, you'll be able to see it later, is a pressure release valve on the other side of this fan. There's a siren at the top, and then next to the siren would be a emergency shutdown button. Just talking about the door, we've got this open door sensor, and it goes off when this door is open and you've powered up the unit. And we've, obviously for today's sake, cable tied it shut to trick it into thinking that the door is constantly closed. But that's a very important feature. And then at the back of the cabinet, you can look at it later, we've got our DN65 standard interface for fire hydrants. And then we've got another pressure release valve at the bottom, and then we've got an explosion relief panel at the top. Now I'm going to take us through the simple process of starting up this unit. The first thing we're going to want to do is turn on the hybrid so that when we feed it with the battery power, it will turn on and start up that backup. The second thing we're going to want to do is turn on this black rotary isolator. Then we're going to switch on all the breakers for the auxiliary power supply. And I just want to talk I want to talk a little bit more about that later, but I'm just going to first continue turning on the unit. That's the AC breaker. So if we had AC power, it would be turning on the unit at already. And then I'm going to turn on, lastly, the DC isolator. So now the red LED, as we can probably see, has turned on. And while this thing boots up the EMU and all the safety features, as I turn that, the safety features have all turned on. I just want to revert back to the auxiliary power supply. You can probably agree with me that it's extremely critical that in most or all circumstances, the safety and EMU and all of the protection devices are on in all situations, basically. So we've effectively made a UPS for the auxiliary power supply. If there's a grid supply or a generator or PV feeding the inverter, it will power up the auxiliary power supply, or like in this case, we've got batteries only supplying there, and it's powering up that auxiliary power supply. That's powering up the EMU. But just talking about not having a grid connection, so today we're going to be black starting the system. We do not have any other power interfaces to the system. We've just got our batteries. I'm going to have to black start this battery, which is not a normal circumstance for most installers. I mean, it might happen every now and again. That's why this is possible. And it's also across battery manufacturers and these types of high voltage solutions. Because it's high voltage, it's probably a good idea to, well, it's definitely a good idea, not probably. It's definitely a good idea to make sure that it doesn't automatically start up when I did the process there, and that you have to press this. And I just want to say that when you do have another power supply, this all automatically happens, so it would be even easier to start up. Now that I told the EMU to start up, I basically told the EMU that I'm comfortable with this installation. Those power leads are correctly connected inside the inverter. When I pressed it, it checked all the safety security around here. It made sure that the temperature in the cabinet was good, made sure there was no smoke in the chamber, and then once it was happy that everything is A-OK, it fired off that control command to the high voltage box to close the internal relay. And we might have heard that little click of the internal relay, and then the green LED is turned on. That's basically meaning that it's letting that the batteries over here run through the high voltage box, and now it's supplying the hybrid inverter. So if we just want to walk over here, we can now see that the hybrid inverter has in fact turned on as expected. And Travis spoke about this. This is the commissioning wizard that we've got. Extremely easy, making it really nice to set up. We've got our clock settings, our meter settings, our battery settings, which we, with this solution, already define the battery for you, because we know that you're going to be using our battery, so making it even easier for the installer. And then we've got our 4 storage modes. As Travis highlighted, this is effectively a 4-in-1 solution. It's 4 components, core components inside one. And for your completely off-grid system, automatically starting your fuel generator can be done with just this hybrid inverter. For another scenario, another case, you can have a large UPS system. That's the aircon just turning on, telling me that the hybrid has started. For another scenario, your large UPS or emergency power systems, the whole system can be handled by this with automatic transfer, extremely quick, just 10 milliseconds. And all, interestingly enough, on one interface. As Travis said, one interface. But this hybrid inverter has got 4 different ways to set it up. You can set it up through the LCD like this, or, and the interface on the mobile app looks exactly the same, but you can set it up through Bluetooth on a mobile app. You can set it up on Solus Cloud completely remotely. And then the 4th interface I want to mention is there's a secondary RS485 port on the bottom of this inverter, which can work concurrently with Solus Cloud. That EMS companies' controllers can send Modbus commands to also set up this inverter, grab data from the inverter, or control the inverter. Now that the AC supply, the inverter's finished booting up, we can come back here and you will see that the other LED on the high voltage box is turned on for AC power, signaling that it's got AC power. And that's what I was talking about with the auxiliary power supply. So now that auxiliary power supply is powered up with both AC and DC. Anyway, that's everything. Thank you very much for listening to me. And now if we could just watch the installation video, which will correlate with a lot on how simple this installation process is. Thank you.